For any assignment-related queries, call us at +1 678 648 4277. You can mail us at support@pythonhomeworkhelp.com, support@pythonhomeworkhelp.com, or reach us at https://www.pythonhomeworkhelp.com. Part A. Permutations of a string. A permutation is simply a name for a reordering. So the permutations of the string ABC are ABC, ACB, BAC, CA, CAB, and CBA. Note that a sequence is a permutation of itself, the trivial permutation. For this part of the set, you'll need to write a recursive function get_permutations that takes a string and returns a list of all its permutations. You will find this function helpful later in the set for Part C. A couple of notes on the requirements: recursion must be used, global variables may not be used. Additionally, it is okay to use loops to code the solution. The order of the returned permutations does not matter. Please also avoid returning duplicates in your final list. Suggested approach. In order to solve any recursive problem, we must have at least one base case and a recursive case, or cases. We can think of our base case as the simplest input we could have to this problem, for which determining the solution is trivial and requires no recursion. For this approach, our base case is if sequence is a single character, there's only one way to order a single character. pythonhomeworkhelp.com. If sequence is longer than one character, we need to identify a simpler version of the problem that, if solved, will help us easily find all permutations for sequence. The pseudocode below gives one approach to recursively solving this problem. Given an input string sequence, base case, if sequence is a single character, there's only one way to order it: return a singleton list containing sequence. Recursive case. Suppose we have a method that can give us a list of all permutations of all but the first character in sequence. Hint, think recursion. Then the permutations of all characters in sequence would be all the different ways we can insert the first character into each permutation of the remaining characters. Example: if our word was bust, we hold out the character B and get the list UST, SUT, STU, UTS, TUS, SU, then UST gives US, BUST, ZUB. ST, SBT, USTB, SUT gives us BSUT, SBUT, SUBT, SUTB, and so on. pythonhomeworkhelp.com. Implement the get_permutations sequence function found in ps4a.py according to the specifications in the docstring. Write 3 test cases for your function in comments under if __name == main __. Each test case should display the input, expected output, and actual output. See the if __name == main __, for an example. Part B. Cipher like Caesar. Ever want to relive the glory days of your youth and pass secret messages to your friends? Well, here is your chance. But first, here is some vocabulary. Encryption, the process of obscuring or encoding messages to make them unreadable. Decryption, making encrypted messages readable again by decoding them. Cipher, algorithm for performing encryption and decryption. Plaintext, the original message. Ciphertext, the encrypted message. Note, a ciphertext still contains all of the original message information, even if it looks like gibberish. pythonhomeworkhelp.com. Caesar cipher. The idea of the Caesar cipher is to pick an integer and shift every letter of your message by that integer. In other words, suppose the shift is kth. Then, all instances of the I letter of the alphabet that appear in the plaintext should become the I plus k, th letter of the alphabet in the ciphertext. You will need to be careful with the case in which I plus k greater than 26, the length of the alphabet. We will treat uppercase and lowercase letters individually, so that uppercase letters are always mapped to an uppercase letter, and lowercase letters are always mapped to a lowercase letter. If an uppercase letter maps to A, then the same lowercase letter should map to A. punctuation and spaces should be retained and not changed. For example, a plain text message with a comma should have a corresponding ciphertext with a comma in the same position. Examples: plain text SIFT ciphertext. abdef hello, world. 2 for any value. deflips, asf. pythonhomeworkhelp.com. Classes and inheritance. This is your first experience coding with classes. Get excited! We will have a message class with 2 subclasses: plaintext message and ciphertext message. Message contains methods that could be used to apply a cipher to a string, either to 3 encrypt or to decrypt a message, since for Caesar codes this is the same action. Plaintext message has methods to encode a string using a specified shift value. Our class will always create an encoded version of the message, and will have methods for changing the encoding. Ciphertext message contains a method used to decode a string. When you have completed your implementation, you can either create a ciphertext message instance using an encrypted string that someone provides you and try to decrypt it, or you can encrypt your own plaintext message instance, then create a ciphertext message instance from the encrypted message within the plaintext message instance, and try to decrypt it and see if it matches the original plaintext message. Your job will be to fill methods for all 3 of these classes according to the specifications given in the docstrings of ps4b.py. Please remember that you never want to directly access attributes outside a class. That's why you have getter and setter methods. pythonhomeworkhelp.com. Don't overthink this. A getter method should just return an attribute and a set method should just set an attribute equal to the argument passed in. Although they seem simple, we need these methods in order to make sure that we are not manipulating attributes we shouldn't be. Directly using class attributes outside of the class itself instead of using getters and setters will result in a point deduction, and more importantly can cause you headaches as you design and implement object class hierarchies. Rules. You do not have to use recursion in Part B, but you are welcome to. There are a couple of helper functions that we have implemented for you: load_words and is_word. You may use these in your solution and you do not need to understand them completely, but should read the associated comments. You should read and understand the helper code in the rest of the file and use it to guide your solution. Part 1, Message. Fill in the methods of the message class found in ps4b.py according to the specifications in the docstrings. pythonhomeworkhelp.com. We have provided skeleton code in the message class for the following functions. Your task is to implement them. Please see the docstring comment with each function for more information about the function specification. __init__, self, text. The getter methods for get_message_text, self. Note: this should return an immutable version of the message text we added to this object in init. Luckily, strings are already immutable objects, so we can simply return that string. Get_valid_words, self. Note: this should return a copy of self.valid_words to prevent someone from accidentally mutating the original list. Build_shift_dict, self, shift. Note: you may find the string modules ASCII_lowercase constant helpful here. Apply_shift, self, shift, hint, use build_shift_dict, self, shift. Remember that spaces and punctuation should not be changed by the cipher. pythonhomeworkhelp.com. Part 2, Plaintext Message. Fill in the methods of the plaintext message class found in ps4b.py according to the specifications in the docstrings. The methods you should fill in are __init__, self, text, shift. Use the parent class constructor to make your code more concise. Take a look at style guide number 7 if you are confused. The getter methods get_shift, self, get_encryption_dict, self. Note: this should return a copy of self.encryption_dict to prevent someone from